Oh. Anyhow, the tetrahedral, you know the MA4, MA3B, MAB3 type, these complexes, it won't show any geometrical isomerism. And similarly, the octahedral complex, yesterday itself I told you, MA6, MA5B, I think very thick. Okay, MA5B. So these complexes, it won't show the geometrical isomerism because of the variation is not there for the ligand. Okay, we should not distinguish one complex with the other complexes because the 5 ligands are same, 6 ligands are same. So it won't differ in the geometrically. Okay. So that's why we given example MA4B2. Okay. I think yesterday I completed MA4B2. This complex show the geometrical isomerism. So only 1, 2 I given to you. The B, same group present in the opposite side means what is that? Same group. Metal. You forget about others. Only this one. Same group present in the opposite side means that is trans complex. Other everything is a cis complex. Okay, cis complex. Don't make a confuse. And here the facial isomerism, meridional isomerism. That's what. Facial means cis isomerism. Meridional means trans isomerism. Okay, there also conclusion. Otherwise, you think about it. This. The cone. Inverted cone means that is cis isomerism. Okay. Okay, the same maybe if you want I discuss other example completely. Sometimes they ask M, A, B, C, D, E. Okay, M, A, B, C, D, E, F. Yes, this complex gives the geometrical isomerism, but it given there almost 15 geometrical isomerism molecule is given. So we should not draw the all 15 geometrical isomerism. Think about it. Total 6 ligand is there. Okay, in that 6 ligand. One you forget, total 5, that 5 it will be alternatively arranged one by one. Okay, therefore 15 times you can, what is it? Yeah, 15 times you arrange the ligand in the different position. So at finally you get the 15 isomers, geometrical isomers for M, A, B, C, D, E, F complexes. Okay, and similarly for the bidentate ligand, bidentate, you write this as sometimes MCQ question. 15 geometrical isomerism is possible for octahedral. All ligands are different. Okay. All ligands are different. So another for maybe M, A, 3 times octahedral line. So 3 times. This is A means bidentate ligand. Example bidentate ligand, ethylene diamine, propylene diamine. Okay, these are all bidentate ligand example. So here, for example, you take it metal, draw the octahedral geometry, maybe ethylene diamines NN, right? Yes, NN, and here also NN. Okay. So if it is like this, think about it. The geometrical wise means maybe now you get a clear octahedral complex. So this is a cis isomerism. Okay, cis isomerism. There is no option to trans isomerism because the donor is same everywhere. Cis isomerism. So cis isomerism normally it's given the optical isomerism because the cis isomerism produce the D and L isomers. Okay, for example, if you keep the mirror image here, okay, if you keep the mirror, you get another one. For example, N metal is here, right? So here, N. Yeah. So it is a D isomer means this is a L isomers. Okay. The rotation of the light in the opposite side, right clockwise means D isomer, left anti-clockwise means L isomers. Okay, D and L isomers. So yesterday itself we discussed the conditions for the optical isomerism. What are the conditions? What are the conditions I given for the optical isomerism? Clockwise means D conformation. Anti-clockwise means L conformation. Optical isomerism. Optical isomerism means the condition is what are the conditions I given? Yeah, definitely. The molecule must have asymmetric nature. That means there is no plane of symmetry, there is no center of symmetry, axis of symmetry. No symmetry means that molecule shows the optical isomerism. And the mirror image is not superimposable to each other. It is a mirror image, but it is not a superimposable one. Superimposable means it is exactly matching. That is superimposed. Non-superimposable molecule given the optical isomerism. So that two conditions. One is molecule must have asymmetric nature. Okay, asymmetric. The second condition, non-superimposable. Non-superimposable. Okay, these two conditions is need for your complex have optical isomerism. Okay, optical isomerism. So there we discussed already in the tetrahedral complex only the ABCD, that complex only show the optical isomerism. Other complex it won't show the optical isomerism. Okay, other complex it won't show any optical isomerism. Right? If suppose coordination number 6, we consider coordination number 6. After that, I will give some questions for overall isomerism. Okay, you try to find the answer. Try to find the answer for that question. It may be helpful for your exam. Only 5 minutes. You finish the optical isomerism. Here they given lot of types like MA4B2, MA2B4, MA3B3, MA5B, AA3, bidentate tries, okay, and MABCDEF. There 15 geometrical isomerism, right? We already discussed the octahedral MABCDEF. See, this one. How many number of geometrical isomerism is possible? 15 geometrical isomerism is possible. So, how many number of optical isomerism is possible? One geometrical isomerism shows 2 optical isomerism because D and the L conformation. So 15 geometrical isomerism, how many number of optical isomerism? 30. 30 optical isomerism is possible for M, A, B, C, D, E, F. Okay. 30 geometrical optical isomerism is there in the complex of M, A, B, C, D, E, F. Because one geometrical isomerism, it rotates left hand side and right hand side, the like direction. So 15 geometrical isomerism produce 30 optical isomerism. So normally in the coordination number 6, the cis isomers produce the given the optical isomerism. Trans isomerism, it won't given the optical isomerism. This is generally you keep it in your mind. No need go for the very depth optical isomerism. That is not your syllabus. Generally, cis means optically active. Trans means not optically active. Because cis produce D and L isomers. Trans, it won't produce the superimposable, non-superimposable images. Okay. That's it. Very simple. We close it. Because otherwise they given long table to discuss. Now this is for competitive exam book. No need that much. Okay, right. So this is a point for your isomerism. Now maybe we go for some example. You try to find it the answer. For example. Okay, this is one complex. They asked the question, what type of isomerism is possible in that complex? What type of isomerism is possible in the given complex? Think about it. This is a square planar complex. What type of isomerism is possible here? Coordination position isomerism. Now only, I told you now, when you come for the question and answer, there only the confusion will be there. How you are saying it produces the coordination position isomerism. What is a coordination position isomerism? When the coordination position isomerism is enabled, it present in the coordination position isomerism in your complexes means change of the ligand within the coordination sphere. Then wherever the bridging ligand is there, there only the coordination position isomerism is possible. Okay, where the bridging ligand is there is no bridging ligand. Then okay, next up. Okay, now that is a discussion. If right or wrong, no issue. You tell me the answer, what you know, we'll discuss it. Then, so one option we ignore it. No coordination position isomerism. Next answer. Yesterday only I told you, when you listen the class, it is very easy for you, but when you sit in the exam, you get confused.
Linkage.
That is generally geometrical isomerism. Linkage isomerism. Okay. Linkage isomerism. Yes. When the linkage isomerism is possible, I given the clue, right? Every ligand I given the clue. Very good. When the ambidentate ligand, yes, this is the ambidentate ligand. Ambidentate ligand is there, therefore here the linkage isomerism is possible. I given one clue. Every isomerism, one clue I given. Linkage isomerism means ambidentate ligand. Ligand isomerism means different donor, but in the one ligand. Example, ethylene diamine, propylene diamine. That is ligand isomerism. Coordination position isomerism means bridging ligand. Right? Coordination isomerism means the two sphere. Coordination sphere 2. That is a one complex. That's why I given example Na plus Cl minus. Na plus one coordination sphere. So plus and minus is there. NaCl. So these complex exhibit the coordination isomerism. Other isomerism is hydrate isomerism. That is very easy. Exchanging the hydrate ion. And counter ion varying isomerism. What is that? Counter ion varying. That is coordination isomerism. Ionization isomerism. When the non-trion will be differ, then it gives the ionization isomerism. Okay, right. Maybe. Now you understood, right? What is the difficulties is there to finding the isomerism in the complex isomerism. Let me discuss more example. Cu NH3, Cu NH3 4 times, PtCl4 with or else versus Cu NH3 Cl PtCl3 NH3. What type of isomerism is possible here? What type of isomerism is possible in this complex? Coordination. That's why now only I explained. This is a plus and minus, two coordination sphere. It exchange the ligand between the coordination sphere, not within the coordination sphere. The ligands are exchanged between the coordination sphere, here to here and here to here. That is coordination isomerism. If the ligands are exchanged within the coordination sphere itself, means La, Lb 3 times, next metal La 2 times and Lb 2 times, La means this is coordination position isomerism. But here coordination isomerism. The coordinated ligand will be varying from one coordination sphere with the other coordination sphere B, that is coordination isomerism. That's what, when we could read the isomerism easy, but when you sit in the exam, it's tough. You practice one by one, okay? CO, NH3, twice Cl2. What type of isomerism is possible? This complex. When we discussed the question and answer, please try to work out yourself. Try to answer. If it is wrong or right, no issue. Don't feel you are wrong. No. Just we discuss. That's it. What type of isomerism is possible here? Anybody please? That's why we classify the isomerism initially, then one by one I explain to you. Here two numbers, here two numbers. M A to B2. M A to B2 means that is not structural isomerism. This is stereo isomerism. In that stereo isomerism, A to B2 produce cis and trans isomerism. Very easy one, right? M, same side or opposite side? A, trans. M, A, B, B. That's it. This type only, na? M, A to B2 type. Cis and trans isomerism. That is, what is that? Geometrical isomerism is possible. Right? We have tried to practice. Geometrical isomerism is possible. MA2. When I discussed that class, I given the hint point for all isomerism. That hint point is useful for you to identify what type of isomerism. This is a MA2B2 type. MA2B2 type tetrahedron means it shows the geometrical isomerism for cis and trans. Yes, cis and trans. MA3B, no cis and trans. MA4, no cis and trans. MAB3 type, no cis and trans. Okay, right. A lot of examples is there. Yeah, best example. Somehow tough, try to find it. Okay. CO NH3 4 times Ap and if we fix it ClH2O Cl H2O 4 5 6 okay with Br2 CO3 plus CH CO NH3 4 times EO NH3 4 times Br H2O Br dot NH3 4 times Br2 with Cl dot H2. This complex, what type of isomerism? this complex. What type of hydrate isomerism? Then hydrate isomerism. Any other answer? Look at the complex and tell me that. Try to find that. Because sometimes one complex it shows so many isomerism. Yes, ionization isomerism. Here the water molecule also exchange inner and outer sphere, and if you soluble this complex, in complex given the Br2 as a counterion, bromide as a counterion. But if you soluble this complex, it given the chloride as a counterion. So ionization isomerism. Ionization isomerism and the hydrate isomerism. Yes, hydrate isomerism also. Example, you take it anything. If COEN2 Cl2, what is the geometry of the complex? What is it? What is the geometry of the complex? The last table, listen. Why you are using the phone? What is it? What is the geometry of the complex? Yes, student, tell me. Very simple question only, na? What is the geometry of this complex? How many of them say tetrahedral? Okay. Anyone? Definitely must raise your hand. Don't simply say. How many of them say square planar? Okay. How many of them say octahedral? Majority people is there. Most of the people they won't raise the answer. I think you don't know anything. That's why. This is an octahedral complex, right? Now only we discussed. Bidentate ligand. Bidentate ligand. So 2En. En means what? En means what?
En is
Ethylene diamine. Pn means what? Pn. They won't given for ethylene diamine and all. You only know. Pn means what? Pn. That is Py. Pn means propylene diamine. Pn means Pn. Triamine. Propylene diamine means Pn. Then triethylene diamine. I think last class I discussed this one. This is the Pn. This is Tn. Propylene diamine 1,3 position is there, that is Pn. 1,2 position is there, that is Tn. 1,2 diaminopropane, Tn.
PN is propylene.
Propylene diamine. Okay, right. Now, these complex TN 1, 2 diaminopropane. The position only vary. 1, 2
What
diaminopropane.
is the common tri?
Complete?
Ethylene.
No. 1, 2 diaminopropane.
No, sir, like the TN 14.
TN, that is group carrying point of view, they say. Octahedral means what? OH. OH is not a short form of octahedral, that is group carrying. Similarly, PN, TN, EN. EN is not a simplified form of ethylene diamine. Similarly, TN means 1, 2 diaminopropane. Position they mentioned. Right. This EN twice Cl2 to form a cis and trans complex. How you identify cis and trans complex for this one? How you identify cis and trans?
Cis is
Only you see the difference. Trans. Cl is opposite side means trans. Others face. That's it. You close the answer. That means the metal is there. Whatever you forget it, only the Cl top and bottom means trans. Okay. Other cis. Okay. Cis and trans complex. Which one shows the optical isomerism?
So this is trans.
Yeah, this trans. Which one given the cis? I told you, I given the clue to you. Normally the cis compound shows the optical isomerism. Trans compound, it won't show the optical isomerism because it won't produce the T and L isomerism because the position is fixed, right? If you keep the mirror here, the same Cl position they say top and bottom only. Then how to distinguish the T and L isomerism? So normally cis complex show the optical isomerism. So you tick the option cis complex show the optical isomerism. Maybe you take this also example. CO, Tn twice, Cl2, CO, Tn twice, Cl2. What type of isomerism? CO, Tn twice, Cl2, CO, Tn twice, Cl2. What type of isomerism? This complex. What type of isomerism? What type of isomerism? Symmetrical. If you have confusion, maybe what type of isomerism is given? Ligand isomerism. Now only I told you now 1, 2, 1, 3. Position of the donor atom it will be varying in the ligand means ligand isomerism. That's why you definitely will get the confusion when you sit in the exam time. This is the ligand isomerism. Only P and Tn will be different. Pn means 1, 3 propylene diamine. Tn means 1, 2 diaminopropane diamine. So that is given the ligand isomerism. So that's it today class. Maybe next class we'll discuss about the what is that? Is that effective? Okay, is that effective and scatter mode everything? Right over. Yeah.
Not
No problem. I'll cut down off only.